If you use Angular 16 or a higher version, then it is very likely that you made already some contact with signals. Now, signals are actually very easy to learn. We just have three functions: the signal, the computed, and the effect. Of course, there are always some kind of edge cases, but in the end, it's simple. The more though you work with signals, the more you get the feeling that something is missing. Especially if your signals contain values which are large object literals, nested object literals, or have quite a lot of properties, or if you want to add some kind of logic on top of them. Now, the Signal Store, the NgRx Signal Store, might be the missing piece of the puzzle here. And there are two perspectives on how we can see the Signal Store. The first one is that we see it as a modern state management library, and this is something which I have done in one of my other videos. The second perspective, though, is that we see the Signal Store as an extension to the Angular signals themselves. And this is what this video is all about. So welcome to this video. My name is Rainer Hanekamp. I am trainer and consultant at Angular Architects, and I will say a little bit about our products, our services at the very end. But for now, I would say, let's get to it. So here we have our application. It's called Conference Organizer. And as we see here, it allows us to organize conferences, talks. So we have here a list of different Angular related talks. And because it's not a very simple CRUD application, we have here an additional feature, which is called polling. So if I say here start polling, then what happens in the background, that my application every half a minute sends a request to the backend, checks if the data has changed, and if yes, it updates the talks, and otherwise it leaves it as it is. And that's why we also have here an information where it says when the last refresh happened. So this was the time when our frontend connected to the backend, and here the last update means that the data has actually really changed. The way how it looks like from the source code is that we have a talk service in the talks component. So if we go into the talks component, we see here it is obviously injecting the service, and we also have then here three different signals that we need to use. So we are requesting here the metadata, which is last updated, last refreshed, and the last editor. We also need to know if we are polling or not. And then we also have here the data source. So the data source is more or less the data of the talks, because we need to show them in the material table. The reason why we had to use three different signals is that, first of all, the metadata is kind of delegated to a subcomponent, and we don't want that this kind of engine changes fires there if maybe something in the talks changes. So that's why we need to have a separate signal only for the meta. The same is true for the polling. So here we say, depending if we're polling or not, we're showing a different button. And then, of course, for the data source, for the material table, we also only want to provide the talks to the material table and not the rest. So that's why we need to come up here with separated signals. We also have here our constructor. So once the component starts or is instantiated, we are triggering the load request, and then we have here the polling, the toggle of the polling feature itself. In our talk service, what do we find there? So first of all, the talk service contains the metadata, the polling information, and the talks in one huge signal. That's what I meant before by having signals which contain quite large object literals. We require a little bit more. It is not exposing the signal itself, not the writable signal, but the read-only signal, so only the talk service can then really manipulate the talk data. That's the hash here means private, ECMAScript private, so nobody from the outside can access that one. The same is true for the find all method. Here we are doing the communication with our backend. We are requesting here the talks. Then we have here the load. As I explained before, it really depends what the backend is returning in terms of last updated. So what find all is doing, or what load is doing, it subscribes to the response, and then it verifies if the current last updated is the same as the one that comes from the backend. If that's the case, then it just updates the last refreshed. And if not, if talks really have changed, of course, then it needs to update the complete signal, as we see here. The data source and the talks. These are also two signals. Why do we require two signals? I mean, we have here the data source, as I've explained before. The data source is the signal for the material table. So we are doing here some kind of mapping from the talks to the way how the component wants to show it. The reason why we have here this additional talk signal is, again, we don't want that this computed here runs if the polling changes or if maybe the last refreshed date was changed. We only want that the computation here is re-triggered when really something in the talks has changed. That's why we had to kind of separate the talks as a computed signal first and then include it in the data source. And then last but not least, we also have here the toggle of the polling. So we are first of all here requesting if we're currently polling or not. If we are, then we are unsubscribing from a potential subscription, and then we are updating the state. We are setting polling to false. And if we are not polling, then we start it. And as you see here, we have here an interval which runs every half a minute by default. And then it just triggers more or less the load request as we see here. And of course, it also sets the polling. So that's the start. Of course, what you could also do is that you can also, in a way, kind of merge the code from the talk service into the talks component. But I think we can agree that maybe it is better to split it apart, even if the service is only there for the talks component. But I don't want to overload my component. And since it is really some part of logic, which is now included in this service, it's actually a good way to split these two things apart. And now let's come to the Signal Store. So what we are going to do is that we will replace the existing talk service step by step via the features that the Signal Store provides us. We will start very simple. We will create a Signal Store that only contains the state and nothing else. So I say here, I have a new file. I call that talk store ts. And I say Signal Store. I say withState. That more or less says, my dear Signal Store, you should now contain the following state, which I'm going to provide to you. And well, I mean, we are going to use the same state as our talk service already has. So I say here, this is the initial value. I want to use the same one here again. And then theoretically, I am already done. Because what the Signal Store is returning me, this function, is a class. Not an instance of a class, not an object, but the class. So I say here, this is my talk store. I could now instantiate the class if I want to. So I could say here, talk store equals new talk store. What does this kind of instance now provide to us? The talk store has, first of all, nested signals built in, or how they call it, deep signals. So the initial value, if we take a quick look, we have here is polling, talks, and meta. The talk store contains all those properties, provides all those properties as signals again. So if I say here, I want to know what kind of type talks here is, then it tells me this is actually a signal of a talk array. So if I want to have if I want to have the actual value of it, then I need to call it because it is a signal. And it's a deep signal. So that means if we go, for example, into the meta, that is a nested object. The meta also has last updated, last edited, or last refreshed. All these three properties, they are again signals on their own. So we see here it's a deep signal of date. And if I say last editor, it's a signal of a string. And again, to access it, I just need to call it. So this is a handy feature, these kind of nested signals, because I don't have to manually create computed or derived values from properties that my signal contains. The second feature that we get is that we have a very simple way on how we can update the state, because we can't use the update function anymore, and there is also no set method. Instead, we have a patch state method, and the patch state method awaits two parameters. The first one is the actual instance of the store, and the second is then more or less those properties that we want to change. So we don't need to provide a clone of our value anymore. We only provide those properties that we want to change. This means if I, for example, say I only want to set is polling to true, then I only need to provide here is polling to true. And the rest, the meta and the talks, they stay untouched. They stay as they are. Only is polling is going to change. And of course, I can, instead of providing an object literal, I can also come up with a function. So I can request here the current state, and then I can say, okay, depending on the polling, I just want to toggle it. So I say here, value is polling. It's more or less the opposite. So patch state nested signals is something we get out of the box if we just use the signal store as it is here. We will, of course, not want to instantiate the signal store as I have done it here manually. We are running Angular, so we have a dependency injection. So we want that this signal store, that this talk store is also available in the dependency injection. And I want to provide it globally, or provide it in the root scope. The signal store also provides a function for that. It's more or less the first parameter here, where I can say, okay, provide in root, like this. Good. That means I can go back to my talk service, and here I can inject my talk store as any other Angular service. So I just say here, talk store inject talk store. Guess I also need to export it, of course. Export const talk store equals talk store, and now it is available. I don't need the talk data anymore, so I can get rid of this one. I can also get rid of that one, and now I can make use of these utility functions. So patch state, for example. I can say here, instead of doing an update all the time, where I only need to more or less override the talk data, I can more or less do patch state. I have my talk store, and I say, well, everything which is in the talk data, override it, and leave the rest as it is. Very simple. For the update of the single property of the meta, it's a little bit more complicated, but not too much. We again need to provide here a function, an updater function, but I don't need to clone the state. That's important. So this makes it very easy. I only say I want to override the meta, and there the metas, I'm creating a clone of the meta property, and then I just say here, well, last refreshed gets now the current date, and I'm done with that one as well. And what's left are then more or less the computed or the derived signals. So we see here we are accessing the data, and actually we want to have the last updated. This is not very easy. So we only need to say here, well, the talk store, and we go to meta, we go to last updated, and we just call it, because the last updated again is a nested signal. So I save it here. What else? About the talks, it's very similar. We replace it here with talk store, and instead of calling here the signal, we're calling the talk signal. And here again, talk store is polling like this. We are done for the talk service, and then we also need to do it for the talks component. Here the talks component also says I want to instantiate the talk store like this, but I don't need access to the talk data anymore. That's not necessary. And I also don't need to come up with here with the computed. I just say talk store please give me meta. And for the polling, it's the same. And now let's take a look at the second feature, which is the generation of computed of derived signals. So if we go to our talk service, we see here that we have this data source signal, which is a derived coming from the talks signals themselves. And we want to move that one to the signal store as well. So I'm going just to copy it, or cut it out from the talk service, go to my talk store, and here the function has the name withComputed. What is withComputed? withComputed expects a function. That function gets access to the current store, which means I have full access to all the nested signals. And what withComputed expects from me is that I'm going to return an object literal, which now contains properties of computed values. So I say here, okay, I'm going to provide the data source, that's it. And instead of saying here this talks, it does exist, but we actually get access to the talks from the store itself. And that's it. Yeah. So if I now go back to my component, I can now request the data source from my talk store as well. And as we see, the talk store kind of merged the state, the slices, so talks, meta, is, polling are actually called the slices, and the computed signals as well. So everything is in one object, literal or in one object together. So I say, okay, I want to access the data source. You see already a little bit the way how it works. So we can kind of build up our store by adding multiple with features. The thing here is, I can also add multiple times a withComputed or a withState. That is possible. So I could, for example, say, okay, I want to have another state. In this case, it's called, I don't know, conference name. And let's just say ngconf, because we have here most of the talks come from there. And that means now that my store in the withComputed now also has access to it, to the conference name. So I can say, okay, I want to include the conference name here as well. And it immediately shows up here as well in the store as a nested signal again. Careful, the order is important. So this store here can only get those kind of properties which have defined before. If I move the withState after the withComputed, then of course I have a problem, because now the store only knows of talks, meta, and is polling. So careful about this. But of course I can switch the withState if I want to. That's not a problem. So as long as the withComputed runs against the state which has already been predefined, everything is fine. The obvious question now is why? What kind of sense does this, or does this actually make any sense? Why would I ever want to provide withState or withComputed multiple times? It's extensibility. This is a feature which I'm not going to discuss here in this video, but what you can do with the signal store is that you can, in a way, group withState, withComputed, other with features, with functions together, provide or put them into a generic function, and this generic function can then be applied to different signal stores. So you can, in a way, come up with a template or with a blueprint, and then in a way very easily come up with different signal stores. Now let's come to the third feature, which is withMethods. So with withMethods, we can very easily, again, extract or add methods, logic into our signal store. Again, let's take a look at the talks service. We have here 3 different methods. We have the findAll, which is a private one. We have the load method, and we have the toggle polling method. And in addition, we also need to have the active subscription somewhere. And we also need to have access to the dependency injection, because our findAll function will require the HTTP client. How does it work? Well, there is now another function which is called withMethods. This function works in the same way as the withComputed. it gets the current instance of the store, and it is expected now from us to return again an object literal with different properties. But this case, those properties, or this time, those properties shouldn't be signals anymore as it was with computed, but they should be methods. So I'm going to copy now all those methods over. So let's just mark all of it, even defined. Let's paste it here and let's start. With methods, when it first runs, so before we are returning anything, we have full access to the dependency injection. That means I can use the inject function here as well. I can say I want to store the HTTP client in this variable. Find all is private, so I'm not going to include it in the object literal that I'm going to return. So I say, okay, find all is now a function which I want to keep in the with methods in the scope. So returns the HTTP client. And then for the load and all the stuff, maybe I'll also copy the polling sub here to the very top. And then I say, okay, I'm going now to return the object literal where I have the load, where I will have the toggle polling, and where I also will have the find method. So 3 functions that I'm going to expose, and then I just need to fix it. So I need to change here from talk store, I need to change everything to store, and for find all, I just call the functions, the function itself, and of course I have to do it now for all the rest here. Okay, finished. So let's check it out how it looks now from the perspective of the component. So my component can now say, okay, talk store, and we see the computed, the slices, and all the methods are directly again merged into the talk store itself. So I can now just say, okay, toggle polling, it's there, and the find all function, because we didn't expose it, is not there. We just have the find function, but not the find all. And of course, we also have to fix it here as well. And I think the talk service is now not required anymore, so we can actually get rid of it, because we have now moved more or less everything from our talk service over to the talk store. So let me remove it, because what we can do now is we can say, okay, well, the talk store is actually not meant to be globally available. It's only there for the talks component, so there is no need to provide it in root. So I can get rid of this one, and I can say, okay, the talks component provides the talk store on its own, if you want. So providers, I say here, that's the talks store, and in that case, it would be locally provided. Okay, so you could now say, looking at the talk store, what's the benefit? I mean, patch state and the nested signals, they are fine, but what about the withComputed and withMethods? Well, with withMethods and with withComputed, we have the advantage that we have, as we have it in the NgRx Global Store, that we have some kind of guideline on how we should structure our code. Don't forget the extensibility. Again, I'm not going to cover it in this video because there is another video that I did where I'm kind of really going into the extensibility quite in detail. Before we end, there is something very important and a very important feature which I didn't show you, and that's the rxMethod, which will help us here a little bit. Because if we look at the withMethods, honestly, it's ugly. We have here a subscription, which maybe is not really necessary or not required, but maybe we can make it a little bit better. What is the rxMethod? Let me quickly go back to the component. So rxMethod, just see here I have an incrementer. rxMethod is a function which generates me another function. And the special thing about this, let's just say I want to have a function which expects a number as an input. And what rxMethod now allows me is that I can kind of treat all the function calls as an observable. So I can come up here with pipe operators. So I say here pipe, and I say whenever this function, which RxMethod generates me, is called, I'm going to execute the tab operator in this case. And I say, okay, I know that I'm getting a number, and I want to kind of print out the value of it. And because we're incrementing here, I want to say +1. Now, this incrementer that we have here is now a function. And I can call it, for example, with 1. And if I do that, then this means, we see it already here, so we have here enabled server-side rendering, that the number 2 is printed out to the console. And this method, the incrementer method, also expects now other observables as input as long as they have the same data type, in this case number. Which means I can say I have an auth, and I have here 1, 2, 3. And if I save it and rerun it, then we get here 2, 3, 4. And it's not just about observables, I can also provide a signal as a trigger in that case. So I can say, okay, I have a number which is a signal of 1. So like this, and then I provide now the signal instead of the observable. That also works for the incrementer or for the Rx method. You see here, yeah, the number 2 is also printed out. Careful with the signals, there is this glitch-free effect. So this means if you say here number afterwards and you set the value to 2, we can't really expect that the output now will be 2 and 3, although not 2, but it will be 3. Because signals, they wait until the synchronous execution is finished. And since the set runs synchronously after the incrementer, the signal of 1 will never be executed there. But we are not going to use the signal there. What we will do is that we will use the Rx method in order to improve our loading method a little bit. So I go into my talk store, and there we have here our load method. And I say I want to now create a new function with the Rx method. So I say here Rx method, and I say I don't really care because the load method didn't have any parameters. So I say here, okay, it's an Rx method of void. It also doesn't have anyone. We have here our pipe operator. And then instead of subscribing, we are just saying here that this is more or less a tab operator that we require here. So I just say here tab. Good, took a while. The problem that we have here is that now, of course, the tab contains or thinks of the talk data as void, but with the possibility now of all the pipe operators, I can easily change that. I can say, yeah, the input is a void, but nobody stops me of doing a switch map here and more or less providing here the find all command, the find all function. Now all of a sudden the talk data becomes talk data type, and we don't need to subscribe. This is now really done by the Signal Store itself. Also, of course, the unsubscription. What we can do now is we have here our polling, and here we can do it a little bit different again, because here we can say, well, we have here an interval. We will still have here the pipe starts with, but instead of saying here we want to subscribe and then call the load method, we just provide here the complete interval to the load method instead. So how does this work? I just say here this load, I provide the interval, and I can get rid of my subscription here. There is a little bit of a problem because the load method says, yeah, actually I want to have a void. You are providing me here with a number or with a boolean. Let's quickly fix this. So we have here a map where we say, okay, I'm going to return a void of true. Yep. Now, as far as it goes for the load, that one's done now. With the polling sub, we still have a problem because it thinks it's a subscription. It is a subscription, but it's not a subscription. It's a subset of a subscription. It's called an unsubscribable, which means it only has the unsubscribe method available, because we still need to unsubscribe here manually from this here, because as a user, I can click on stop polling, and then of course the unsubscription needs to happen here as well. But with the Rx method, you can very easily kind of integrate the power of observables of RxJs into a signal store. You don't have to, it's an optional feature. And as you have seen, the subscription is also not necessary, because with rxMethod, the signal store will take care for you if you don't do it. In our case, it goes with the provided scope. And since the talk store is provided by the component, the unsubscription will also happen when our component is getting destroyed. That's it. And as I said in the beginning, a little bit of promotion. So we are providing workshops about NgRx. The Signal Store is part of the Enterprise workshop and of the NgRx Advanced workshop. The workshops have fixed days, but of course you can also book them individually, remote or in-house. So we have seen that the Signal Store really enhances the functionality of our signals. With withState, it is very easy to modify a signal which holds a large object literal. The Signal Store also has these nested signals, so we don't need to create them manually all the time. And with the feature functions, withComputed and withMethods, we can merge logic and derived values together in a single service. The crown jewels though, the extensibility of the Signal Store, is something that I haven't discussed in this video. If you're interested, I highly recommend it, and please watch my other video where I go into detail. Other than that, if you have any questions, any comments, then please let me know. I would be happy if you like my video, also if you subscribe to my channel. That's it. Thank you very much and see you in the next video. Goodbye.